Welcome. On this channel, I do unscripted, unedited videos about Linux programming and stuff. Recently, I have been working on relearning C. It's been about 25 years since I've used it. And most recently, I've just been exploring various common operations, file operations, memory allocation, and things like that. Today, right now, I am going to take a look at calloc, so the continuous alloc. I had started down that path the other day and got distracted by a small bug I couldn't sort out at the time, and I now have that worked out. Projects, C stuff. So with each video, I've been making a new folder, and I am going to move 018 to be it was incorrectly labeled as calloc. It is actually malloc, and now I am going to create copy 020, and it will become 021 calloc. Clear. And calloc. So, quite similar, right, to malloc. It takes a size. I mean, the difference is that it takes a size of a record and a quantity of records. So the number of members and the size of each member, and it allocates that memory. So effectively allocating an array. Down here, it calls out if the multiplication of that would overflow, it does return an error. By contrast, an integer overflow would not be detected when calling malloc. I'm not exactly sure. I mean, I guess you'd have to be doing math inside of the call for the integer overflow to happen. If you'd already done the math, there wouldn't be a chance of integer overflow. Okay, so I think that they're suggesting there that calloc is the preferred way to allocate memory. So let's take a look where we left the source code off. We have this. Okay, so main is pretty straightforward. We're taking the arguments that are passed to it and iterating over them. We're assuming that each of those is a file that we can load. If we're able to load it, we end up with the buffer pointing to the contents of that file. Otherwise, if we get a 0 back indicating we weren't able to read it, we just continue with a loop. Once we have the contents, we simply iterate over it, printing out every character and freeing the file. The thing I want to do now, I mean, this isn't going to make sense from like being practical or intelligent, but I want to experiment with it, is that I want to essentially allocate. I want to do two things, and I guess maybe this is going to end up being, multiple videos, but just for the learning experience, I think that I would like to create an extendable array of memory holding slices, slices to all of the lines that are in this buffer. In other words, once we have the buffer, we're going to scan through it. We're going to find every line feed and establish and push a slice, a structure of a slice, onto an extendable array, so we have a big long list of lines that we can iterate through. Doesn't really make sense probably from like a performance or practical reasons, but it will teach me an awful lot, almost certainly, as I work my way through this. So I think the first step, right, is we have the buffer. We're going to iterate through it. I think the first step is just to establish the slices without even saving them. And then the second step is to save them. So maybe we never get to the CLOC in this video. Maybe this is just about the slices. Well, what does the slice look like, right? So we need to, we'll end up having let me do it this way. Right, so we're going to end up defining a struct. And that struct, so let's do struct. Let's do it this way. Struct slice. Probably should do this with a typedef, but we're going to have the data and the length of the data, right? So, except for I want to change those around. So that is our slice. I think that we can define. So if we do this with a typedef, we can just write. We can create our variables easier. So I want to take a look at that. Again, kind of on the edge of my knowledge, I just don't remember. So I need Chrome, programming, C, typedef, struct. C typedef. So it's just, typedef creates an alias for a type. So here we're saying typedef long is LL, right? And then let's go back up here and find it. So then you're able to define a variable of LL, of type LL as A. Okay. Often, I don't think it helps in C. Well, it might. Actually, I want to check that. This can actually help often with type errors, assuming that you don't get any kind of auto conversion. So let's actually check that out, because that's useful to know. So make sure I introduce no bugs so far. Let's create. Let's do exactly what they did. Long. And actually, it's not the struct that I want. It's a typedef of long to LL, and typedef of long to II. Right? Okay, so we have these two types. We know that they actually have the same underlying type. Can I then say, hey, I want to create a LL equal to 24, and then I want to create an II and assign that LL. Will that compile without error? On line 55, expected identifier or I'm going to bring these down here since I'm going to be playing with them. I don't see the... Oh, I never created a variable. And then I want Jew. Okay. So let's just do the one. Warning, unused variable. Okay, so let's just print it out. So we'll printf, and I'm going to go up here. I just want to change these to, oops, I already moved them. Let's just change these to longs. Actually, let's just make them ints. Okay, so now they're both ints. Right? Okay, no problem. Now, can I assign A to II? Error, expected, why was I, B? Warning, unused variable b. And it does not complain about about them being two different types, right? B, because the underlying part is, if it did, that would be great, because then you can define types and not accidentally convert between them. Let's see if there's any tools to help enforce that. C, prevent implicit conversion is the word I wanted. You can't do that with typedef. Use the following instead. This happens to not be C. Can I prevent you? So typedef blah blah blah. One technique borrows from modulas opaque types. That's probably good enough for preventing conversion with int. It also follows another member variable. Oh, are they suggesting that if you just make it a struct, that's enough to prevent it? So what they would be saying here is, so typedef a struct that has a int in it, and of course I'm going to have to give it a name. So we'll say int x. Do I need the semicolon when I do that? I do. And I have to give it a name now. So we're going to call it ll. And then struct int y ii, right? And now to do the assignment, I think I have to do so. So let's back up and do this one piece at a time. So, ooh, had a mess up here. Must have been a little bit of help from Copilot there and me not tabbing. Okay, so got that. Is that the right way to warning, unused variable, blah, blah, blah. Okay, I can, and what I want is a dot x, right? And now can I could do that, right? But this is actually what I wanted to find out is, can I do, could I do this, for example? Error, incompatible types while initializing II, blah, blah, blah. Now, I would need the address, right? So I think that's the first thing. Initialization of II pointer, incompatible pointer per type LL. Warning, unused variable. Yeah, so I think that if you really want to enforce not being able to share, not being able to implicitly convert between typedefs, that works. I am not going to go that far right now. Although in the future, I do see an awful lot of my types being structs, because instead of like using just raw pointers for most things, I'm going to be like, I'm not going to be using raw string pointers often. I'm going to be using slice pointers, slices. And so all of a sudden, you don't accidentally convert these things. Okay. So I want to have a struct right now that is called a slice. And in that slice, I want, it's basically this. It is that, but I'm just changing the, so we're going to have a size t, which is length and we're going to have the actual data. Excuse me. Sorry. Oops. Snuck up on me. Okay, so right. Make sure I didn't leave anything up there. So we have our typedef to a struct called slice. If I want to make a slice, I can say that I want a slice called s that is equal to exactly has a 0 length and a null, right? Null pointer. That should build. Does not. A undeclared first use in this function. F118. That is because A doesn't exist. We have a slice, and the only thing of interest here is going to be, I think ZU, I'll look that up in a second, is size T, and so length. Okay, so let's do a couple of functions just quick. So I want to do we can return void, and we can have slice inspect. And slice inspect is just going to take a slice pointer, yeah. And what it's going to do is the first line is right. So we're going to print out slice ZU, the length, and then I don't actually want to iterate over the length and put the characters. Yeah, actually, let's do that. That's actually, I like that. And then, so basically we'll put out the string. That's not a particularly great way to do it, but oh yeah, I guess we're not relying on the fact that it has a that it ends in a null in a null byte, right? It's not zero terminated, so we kind of do have to do it that way. Okay, so let's try this out. If we call slice inspect on S, the address of S. And what we do here is we say that this is equal to, actually I don't know how to do this for sure, but I'm guessing that this will work. Hello world. And then that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's 11 bytes, and just to be safe, I'm going to say 10. We should come up a character short. Okay, so for the time being, let's just exit here. And we get hello world, 1 character short, just as I had kind of assumed. Where is... Oh, there. We can't use the string length. We have to use s.length. Hold it, that isn't right. I'm creating the slice here, so I don't... what I could do is... and I think what it's going to do is it's going to give me 1 too many characters. So if I say string length of greeting, and then I pass greeting, is that even remotely right? So I can define blah, 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 the string value, static constant character. Okay, so I'm trying to figure out if there's any advantages here. Obviously, I could just do that, right? C programming constant string. That's how do you declare a string as constants? This person's trying to do what I was just doing, or is this better? And that's what I think we should be doing. There's one more, at least, road to Rome. The define has the advantage of compile time, concatenation, think hello world, and you can size of hello as well. But then you can also prefer constant character and use it across multiple files. So this seems valid. What did I do wrong? Define something, the string. Define something, the string. That seems valid. Then, okay, let's start with something simpler. Let's just puts the string. Oh. How do you spell greeting? No, that looks funny to me. No, it's two E's, right? Okay, wasn't imagining that. Did I have it as wrong? Oh, I had it wrong here. Is it two T's? No, it's one T. Okay, little things matter. I think that was the only mistake, right? Okay, so that works just fine. I can do greeting, one T, string length, 1T, error expected expression before a slash. Where was that? Oh, unused variable s. So we make a slice s, and then, oops, we never, there we go. What I actually want to do is slice. I'll eventually develop a standard way to inspect everything, but for now, what I'm going to do is length equals ZU. And this is going to be P to get the address of S, and that'll be the length, and then new line, and we're going to start indented 2, and that'll be confusing, so printf right? Yep. Okay, so just a quick and dirty, we can inspect a slice now. Kind of a little roundabout way to do things here. Okay, now we have a slice. What I want to do is I want to find the end of slices, and whenever I find the end of a slice, so we're gonna keep track of the index. No, j is our index. But what I need to keep track of is the last time. So we need to keep track of the slice start equals 0, right? And then what we're going to do is, if the buffer j is equal to a line end, we're going to make slice s, which we don't even have, so it's telling us, but it's right. I need a slice s that equals that has a length of 0 and a we're just going to clobber this one every time, right? So slice s. We're keeping track of the start of the slice, which starts out at 0. If we find a line feed, we are going to set slice s's length equal to j minus slice start. We're going to set its data to buffer plus slice start. Yes, that's good. We're going to call slice inspect. Sometimes Copilot kind of surprises me. We're going to slice start. Then we're going to advance the slice start to 1 pass where we're currently at. That's good. And so what we should get is slice start. Why are those different? Slice, S-L-I-C-E. So it's finding it when I search. Okay, they are the same. What do we get when we build here? Warning, format P expects argument of type void. Yeah. Okay, so let's go up here. This should be a void pointer, cast to a void pointer. Get rid of that error. Slice start undeclared first use in this function. Did you mean slice inspect? Demo C at 72. Oh, the slice start is what is J is size T. Oops, slice start. Okay, warning, unused variable S. Okay, we don't actually need to create it here because we're creating it directly each time there. Okay. And we are printing out all of the lines. We have sliced it. Okay, so that is it for this. I mean, that was pretty basic, right? But that was the immediate goal, right? So we created a slice type. We turned it into a, we identified the slices. We made each slice. The thing I want to do now is I want to append each of these to an expandable array. So I have a big long, I mean, again, this isn't smart or data efficient, isn't efficient in any way, but it is just practice doing things. But once I have the expandable array, then I could, in theory, you know, manipulate that as a more interesting data structure. So that is where I am going to leave off this video. I will see you in the next one.